Welcome to Unit 4, Lesson 2, Square Roots and Cube Roots. Let's think about square and cube roots. Again, here are exponent laws, which are going to be necessary for most of this unit. Okay, find the area of square ABCD. So that's the square, I'm sorry about that. That is the square right here. We want to find the square, the area of the square. All right, what we have to remember is the area of a square equals side squared. Area of a rectangle is length times width, but in a square, the sides are the same, so it's the side squared. So now, we want the area. The first thing we have to do is find the length of this side. But luckily, we have these things. So, when we have a right triangle, we use our good friend Pythagoras. 2 squared plus 3 squared equals c squared. The square of the sum of the legs is equal to the square of the hypotenuse. 4 plus 9 equals c squared. 13 equals c squared. When you solve an equation, you cannot leave a c squared. You must have a positive 1 exponent. And when you solve an equation, you must have a positive 1 coefficient. So to get rid of a square, we have to take the square root. So the square root, the leg, one leg is equal to the square root of 13. So now that we find that, now we can do the area. The area is equal to the square root of 13 squared. When you square a square root, they undo each other. The area inside the square, all of the space inside the square, the area is the space inside, is equal to 13. Now, a long way to do it is to calculate the length of the big square and subtract all the area of the little square, which somebody in class was brilliant enough to do. So the length of the big square is 5, so equals 5 squared, which gives us 25. That's the area of the big square. And the area of a triangle is 1/2 base times the height, which gives us A equals 1/2 2 times 3, which is 1/2 of 6, which is 3. And since there are 4 triangles, if you multiply it by 4, you get the area of the space is 3 plus 3 plus 3 plus 3. And if you take 25, the area of the big triangle, subtract out the area of all 4 triangles. Why did I write 14? That's 12. You get 13. 25 minus 12 is 13. And that's what we calculated. So there's 2 ways to solve this problem. Okay, what this is trying to get you to see geometrically, area deals with all the space inside of a square. So our square side length is 1. Area equals side squared. So 1 times 1 is 1. So the area of the first triangle, of the first square A, is 1 because the side length is 1. Now, it gets a little tricky with the ones you can't see. But our length here is 2, which means this is 1, this is 1. If we make a right triangle out of it, 1 squared plus 1 squared equals 2. That's c squared. But the length of this length, we'll call this little b. B squared, according to Pythagorean's theorem. And then we take the square root to get positive b is root 2. Okay, now this one is easy to see. We got 2 lengths. Area equals side squared. 2 lengths on this side, makes 2 squared, which is 4, and you can see 4 boxes as the area, so that's easy to see. With the last one, it's a little more difficult. Now what we're going to do is go here to get some measurements. This is 2, this is 1. 1 squared plus 2 squared is 1. 1 times 1 is 1, plus 4 is 5. Little d squared equals 5, because d squared equals that. And d equals root 5. So d is equal to root 5. Now we come back and square it. Root 5, u squared, a equals 5. I know that was a lot. That was a lot to do these, but they're just trying to show you geometrically how area works on a square pattern. So, last one. This length is 2. This length is 2. 2 squared plus 2 squared. 4 plus 4 equals 8. Equals little e squared. E equals the square root of 8. The area of E is root 8 squared, which is area equals 8. You can count 1, 2, 3, 4. If you put these two together and these two together and these two together and those two together, that's 4 more. And that's how you get to 8. Okay, this figure went with the previous one. So if the area was 4 and we take the square root going down, so go down, you take the square root. To go up, you square whatever. So the area was 2, the answer was root 2. The area was 4, the square root of 4 is 2. And so on and so forth. I'm going to leave the rest of the table blank. Okay, the previous problem was supposed to help us understand this one. Area is square, is the side length squared. So to go to area from side length, you square it. To go from area to side length, you take the square root. Squares and square roots are opposite. Equal and opposite, like multiplication and division. So let's go to the first one. We got the area. To find a side length, we need to take the square root. So the square root of 9 is 3. So we do root 9. So if we're given a side length, to get the area, we have to square it. And that gives us 16. And the square root of 23, oh, that's just root 23. 6.4. Are we given a side length? To find an area, we have to square it, which gives us 40.96. And then the last one, 89. To get side length, we have to take the square root. Do not write the decimal down because the decimal is an approximation. When you take the square root of non-perfect numbers, and you'll have to refer back to the preview of the unit video, non-perfect numbers are irrational. The decimals never end. They never stop. They never stop. They never repeat. So we're going to leave this table. When you have non-perfect numbers, leave it as a radical. Just like squares and square roots are opposite. So if we x squared, if we take something and we say x squared, the opposite of squaring something is taking the square root of it. Okay, so 3 squared equals 9. The square root of 9 equals 3. You have cubes and cube roots. Cubes deal with volume. So x cubed is the opposite of the cubed root. Now, mathematicians are a little lazy, and you have to watch the preview video to Unit 4. There's supposed to be a 2. It's called the index. The funny-looking division symbol is called the radical, and the number under the radical is called the radicand. If there's no index or root, it's understood to be square root. For every other root, there has to be a number, so we know it's not the square root. Because mathematicians are lazy. There's no first root, no such thing as the first root. You start at the second root, because what we were trying to show you is that an area, if you take the square root of the area, you get the side length. If you square the side length, you get the area. The same thing with cubes, but instead of area, you get volume. If you take a side length and cube it, you get volume. If you're given volume, you have to take the cube root to get to the side length. So let's pay attention to the wording. A cube has an edge length of 3, which means we must cube 3. 3 times 3 is 9. 9 times 3 is 27. So the volume equals 27. A edge length of 4. 4 cubed is 4 times 4 is 16. 16 times 4 is 64. So the volume, let me do this. 4 cubed equals 64. So the volume equals 64. Okay. Now watch the next one. This is where it gets different. Volume. You're given volume. To get rid of volume, to find the edge length, you take the cubed root of the number. And the cube root of 8 is 2. Why did I write 8? I meant to write 2. So this 3 is not 3 times the cube root of 8. It's the cube root. So it should be a little bit smaller, and it should be written closer to the radical so that we know it's the cube root. Okay. A cube has a volume of 7. So to get side length, you have to take the cube root of 7. 7 is not a perfect number, so we're going to leave the edge length, the EL, as the cube root of 7 because it's a long irrational number that never stops and never ends. For number 5, the cube root of 1200 is between 10 and 11 because 10 cubed is 1000 and 11 cubed is 1331. Determine the whole numbers that each of these cube roots lie between. So the first thing you should do is write down your cubes, your perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is, I always trip up with 9. 729, and 10 cubed is 1,000. Now that we know these basic ones, now we can figure out which perfect numbers these lie between. So the cube root of 5 lies between 1 and 8, and 8 is 2. So this number lies between 1 and 2. The cube root of 10. 10 is in between 8 and 27. So the cube root of 8 is 2. And the cube root of 27 is 3. So this lies between 2 and 3. 50 is in between 27 and 64. So that gives us 3 and 4. 100 is in between 64 and 125. So this one would be 4 and 5. And 500 is in between 7 and 8. I should put this in orange. Because 7 is 343 and 8 is 512. So 7 and 8. So these are not perfect cubes. Your perfect cubes is the list I wrote for you on the right. And these are the perfect cubes. You should memorize these numbers, the first 10 perfect cubes, because they come up a lot in math and science problems.